discounted payback period. Now, discounted payback period is an improved version of the simple payback period. But under discounted payback period, we consider time value of money, which means that 1 Ghana cedis we have today, which is 2023, is worth more than 1 Ghana cedi we would have a year after. Or $1 we have today is worth more than $1 we would have a year after. And so under this method, which is the discounted payback period, we are going to discount all the cash flows. And all these cash flows are future values, are in their future values. And so we are going to discount them, bring them into their present value. Then we do our calculations. So we would use the discounted values at this rate of 12% to calculate our payback period. So quickly, let's do. Then, because we are discounting the cash flows into their present value, we are going to apply the PV formula, which is PV equals FV, which is our future value, on 1 plus R exponent n. So this is our present value equals our future value divided 1 plus R and exponent n. Now R is the discounting factor or our interest rate, and then the n is the year or the period. Okay, so now we are going to take each cash flow one after the other, calculate and fix it here. Then we'll use the payback method formula to check which of these projects has, or which of these projects is more attractive or would have to accept under the discounted payback period. So we take the first year under project A. So the first year we have our future value. Remember, our cash flows are all in future values, and so we are discounting them into present value. We have our cash flow for this first year to be 210,000. So our future value is 210,000 on 1 plus. Now our discounting factor, or our R, is 12%, and 12 divided by 100 is equal to 0.12, right? So plus 0.12. Exponent is just 1 year, so you can just write 1 or you leave it like that. It is still okay. So our PV equals 210,000 all on 1.12 exponent. So our PV for the first year for project 1, or project A, the first year for project A is 187,500. So right here, 187,500. Okay, so we'll move to the second year's value, which is 115,000, right? And our PV is still constant. PV is equal to 115,000 all on 1 plus 0.12 exponent 2. It is exponent 2 because this future value is the second year's cash flow of the project A. So PV equals 115,000 1.12 exponent 2, and we are going to have 91,677.296. Okay, so when you come to the table, we have 91,677.296. We do same for the third year, which is PV equals, the third year's cash flow is 105,000. So 105,000 on 1.12 exponent 3. And that is going to give us 74736.926. Okay, so the third year is giving us 74736.926. And then the fourth year, applying the same formula, the fourth year is also giving us 31775.90. Very good. So for our project A, our discounted cash flows, these are discounted cash flows. Our discounted cash flows for project A, the first year is 187,500, the second year is 91,677.296, in that order. So we are going to go straight, calculate the payback period for our project A. So we are calculating the payback period for project A. So payback equals the year before full recovery plus remaining balance all on. Remember, we are using the same formula for the simple payback period. So remaining balance all on the cash flow for the year of full recovery. Okay, so the payback period, we stated it in the previous video, and so the year before full recovery plus the remaining balance divided by the cash flow for the year of full recovery. Now, when we come to our discounted cash flows or discounted values for project A, we have 187,500 here. Now, we are still working towards 260,000 as our initial investment. The initial investment remains unchanged, and so we are going to work with our discounted cash flows values or discounted values to see which period or which year we are going to recoup our 260,000 initial investment. Now, first year is giving us 187,500. So 187,500. We have our initial investment of 260,000. Now, how much are we left, or what is the remaining balance to add up 287,000 to get 260,000? And that is 72,500. So this is what we are looking at for after the first year. Now, our second year's discounted value. Our second year's discounted value or discounted cash flow is 91,000. But we only need 72,500 to be able to recover our initial investment of 260,000, which means the first year becomes the year before full recovery, because we are going to make our full recovery in the second year. So the first year becomes our year before full recovery plus the remaining balance. So the remaining balance, we still state our 260,000 minus the first year's value, which is 187,500, all on the cash flow for the year of full recovery. Now, we are going to need only 72,500 from the second year's value, add up to the first year's discounted value, then we can recover our initial investment of 260,000. And so the cash flow for the year of full recovery, it is in the second year that we are going to make our full recovery. So we state the second year's value there, which is 91,677.296. Now, the difference here is that with the discounted payback period, we are only using our discounted values, the values that we calculated here. We are only using our discounted values to calculate for the payback period. So instead of the simple payback period, the usual payback period, where we use our cash flows from the question to calculate, now we are using the discounted. We have discounted all the initial cash flows, which are in their future value. We have discounted them into our present value, which comes in this way, and then that is what we are going to use to calculate for our initial investment of 260,000. So we go ahead. Now we have 1 plus 260,000 minus 187. 260,000 minus 187,500. We are going to get 72,500 all on 91,677.296. All right. So this is what we have. So 72,500 on 91,677.296. Now we are having 1 plus 0.7908. Now our payback period is 1 plus this, so 1.79 or 1.8, which means that with our discounted payback period, we would be able to recoup or recover our initial investment of 260,000 under Project A in 1 year, 1.8 years time. And so in less than 2 years, we are going to recover our initial investment under Project A. So we can do same for Project B in that order. Then we'll get to know which of these projects under the discounted payback period is more attractive for us to accept. So I'm going to I'm repeating the same PV formula. So PV equals FV on 1 plus R exponent n. Now, under Project B, our first year's cash flow is 30,000. This is in future value, so we are discounting it into present value. So PV equals 30,000 all on 1.12 exponent. And so that is going to give us 26,785.714. Okay, so for the first year under the discounted payback period, Project B is going to give us 26,785.714. Good. Now we calculate for the second year's PV. We have 130,000, which is 130,000 all on 1.12 exponent 2. You make it exponent 2 because you are calculating for the second year. You go to third year, you make it exponent 3. You go to fourth year, you make it exponent 4, in that order. And now for the second year, we are getting 103,635.204. So 103,635.204. In the third year, we are getting 163,709.457. And in the fourth year, we are getting 38,131.085. So these are future values, and these are present values. Future values for Project A, which are the future, which are the cash flows that the question gave us, and this is the discounted values or the present values for the project. Now we would have to calculate the payback period or the discounted payback period for project B. So we are going to use the same formula which states the year before full recovery plus remaining balance all on the cash flow during the year of full recovery. So payback period is equal to year before full recovery plus remaining balance all on the cash flow for the year of full recovery. Okay, so year before full recovery, now we are still working at 260,000 as our initial investment. The first year, our discounted value was 26,785.714 plus 103,635.204. That is giving us 130,000, but our initial investment is 230,000. So we would need about 100,000 more to recover our initial investment of 260,000. And so we are going to get that remaining balance in the third year. So the year before full recovery is 2, because it is after 2 years that we are going to make our full recovery in third year. So plus the remaining balance. So the remaining balance here, 260,000 minus 130,420.918 all on. So the remaining balance, you state your initial investment here, and then you add the first year's value and then the second year's value, because it is after the second year that we are going to make our full recovery. But the third year's discounted value is more than the remaining balance, so you subtract the first year and then the second year's value from the initial investment, then you get your remaining balance. And then it is during the third year that we are going to make our full recovery, so you state the third year's value here, 163,709.457. Now we have our 2 plus 260,000, which is our initial investment, minus 130,420.918 is going to give us 129,579.082 all on 163,709.457. So this is what we have, 163,709.457. So we have our 2 plus 0.7915. You are going to get 2.7915 or 2.8 years. Okay, so under the discounted payback period, project A took us project A 1.7, and then project B 2.8. So between project A and project B, under discounted payback period, project A, it will take us it will take project A 1.7 year to recover its initial investment, and under payback period, the interest is on the length of time a project will take to recover its initial investment. And so, comparing or taking the rule into consideration, we say that project A is more attractive, hence we would have to accept project A and take. So that is that for the discounted payback period. So we shouldn't forget that under the discounted payback period, we would have to discount all the cash flows which are in their future values into their present